Good morning, good afternoon, or good evening. Let's get to multiplying matrices. This is Mr. P signing on for section 13.4 in your honors section of secondary math 2. So in order to determine what dimensions the resulting matrix will have if you multiply them, you count the number of rows in the first matrix and the number of columns in the second, and then what would be the number of rows by the number of columns of each one, n by n matrix. That is, if you count the number of rows in the first matrix, this is a 1, 2, 2 rows, and the number of columns, well, there's only one column, then it would be a 2 by 1 matrix. It would be 2 rows and 1 column. For what it's worth, I prefer doing this a different way. I like thinking of it like this. 1, 2, 3, 4, and if I put 5, 6, what I'm multiplying it by up here, look at that. We've left a little bit of space underneath, and what fits in that space is our matrix, which we can see is 2 rows, 1 column. So let's count the rows, 1, 2 rows, and 1, 2 columns, which means this is going to be 2 by 2. But again, I prefer looking at it like this. 0, 1, 2, 3, 4, 5 times 6, 7, 8, 9, 1, 2. And there's just enough room down here for a 2 by 2 matrix. Okay. When multiplying matrices, you multiply the rows of the first matrix by the column of the second matrix. For example, multiplying 2 by 2 matrices. Let me go ahead and show you how this works. So I set it up like this. 4, 0, negative 9, 1. And then above it's going to go this, 8, 0, 2, negative 1. That leaves space for a 2 by 2. And what I do is this. 4 times 8 plus 0 times 2. Notice I'm multiplying this row by this column, the first row by the first column. Why add them? Well, that's the way that we've defined it to be. But think of it like this, is that these all point to one spot and one spot only, here. That's what's going to go in the first entry. So the first entry is going to be 4 times 8 plus 0 times 2, which is 32, plus 0, which is 32. Now we're going to go 4 times 0 plus 0 times negative 1. See what I've done there? I've multiplied the first row by the second column to get what goes here. And that's going to be 4 times 0 plus 0 times negative 1, which is 0 plus 0, which is 0. So that's a 0. Let's do the next one. So if I do negative 9 times 8 plus, I'm going to leave it the same color, 1 times 2, I'm going to get the result here, the second row by the first column. Negative 9 times 8 plus 1 times 2, which is negative 72 plus 2, which is negative 70. And finally, I'm going to go ahead and multiply these by taking the second row and multiplying it by the second column. Negative 9 times 0 plus 1 times negative 1. Negative 9 times 0 plus 1 times negative 1, which is 0 plus negative 1, which is negative 1. And so there it is. That is the resultant matrix when we multiply them together. Okay, let's do that with this one. So again, I set this up 1, 2, 4, 3. And then meeting corner to corner, 0, negative 2, 1, 0. Makes a resultant 2 by 2. So we're going to go 1 times 0 plus 2 times 1 gives me this. The first row times the first column. 1 times 0 plus 2 times 1 gives me 0 plus 2, which is 2. Whoop. Switch over the colors. Now, 1 times negative 2 plus 2 times 0, the first row times the second column, gives me this. First row, second column, entry. 1 times negative 2 plus 2 times 0 is negative 2 plus 0, which is negative 2. Whoop. Next, 4 times 0 plus 3 times 1 is going to give me that right there. For second row, first column, second row, first column. 4, 0 plus 1 times 3, which is 0 plus 3, which is 3. Whoop. One more, shall we? Then this song will be over, and you will be sad, I'm sure. What haven't I used? Orange? Orange it is. All right. 4 times negative 2 plus 3 times 0 would give me that. Second column, second row, second row, second column, second row, second column. So 4 times negative 2 plus 3 times 0, which is negative 8 plus 0, which is negative 8. That goes here, and you're done. Whoop! We did it. So just multiply into those zones like that. Now, they don't have to be matching, and in fact, some matching matrices can't be multiplied together. So in order for matrix multiplication to work, the rows in the first matrix must have the same amount of numbers as the columns in the second matrix. That is, each of these rows, which is only one row, this row has two entries, and these columns have 2 entries. So multiplying these will be just fine. Here's how we do it. 6 or negative 6 and 2, and you put that to the corner of 2, 1, 4, 4, 6. So you can see the results of 1 row, 3 column matrix. So here we go. Negative 6 times 2 plus 2 times 1 is negative 6 times 2 plus 2 times 1 is negative 12 plus 2, which is negative 10. Negative 10. And again, negative 6 times 4 plus 2 times 4 is negative 6 times 4 plus negative 2, being positive 2, 4, which is negative 24 plus 8, which is negative 16. And last but not least, oops, already used that one. I'm going to use a color that's going to clash with it. There you go. Negative 6 times 6 plus 2 times 8 is negative 6 times 6 plus 2 times 8, which is negative 36 plus 16. And I'm too lazy, so here's my calculator. Negative 36 plus 16 is negative 20. There is our 3-entry matrix. Very good. So again, to see if it works, the rows in the first matrix have the same number as the columns in the second matrix. So the rows in the first have 3 entries, and the columns only have 1 entry. So you can see this one's not going to work. But let's see what happens. 2, 4, 6, 1, 4, 8. Kitty corner from negative 6 and 2. So in theory, I should have a 2 by 2 matrix, but look at this. If I try to multiply this row by this column, I can't, because 2 times negative 6 plus 4 times, there's no one to go with 4, which is why we say that this is undefined. Hey! Okay, so let's set her up. Well, again, each of these have 2 in the 3 in the column, 3 for each row, 3 in each column. This should work. So 1, 0, negative 2, negative 1, 3, 0. Thanks for all the zeros. This is going to make our life a lot easier. Trust me. 0, 3, negative 2, negative 1, 0, 4. Which is going to wind up giving us, looks like a 2 by 2 matrix. So this row times this column is 1 times 0 plus 0 times -2 plus -2 times 0. And I hope you don't mind that I just say that 0. Yay! Over here. Hey, that was supposed to change the color. Yeah. This row times this column. 1 times 3 plus 0 times -1 plus -2 times 4 is 3 plus 0 plus -8. And 3 plus -8 is -5. This row times this column. 0 times -1 plus 3 times -2 plus 0 times 0. Nice, nice. 3 times -2 is -6. And last, but certainly not least, is this row times this column to get this entry. So, -1 times 3 plus 3 times -1 plus 0 times 4. -1 times 3 is -3. 3 times -1 is -3. 0 times 4 is 0. -3 plus -3 is -6. There's our resultant matrix. Phew. This one should work too, because it's got each of these rows has 2 and each column has 2. So you go 0, 1, 1, 1, and -4, -9. 0 times -4 plus 1 times -9 is 0 plus -9, which is -9. Second row, only column, 1 times -4 plus 1 times -9 is -4 plus -9, which is -13. And so there's our resultant matrix. Okay, that's all I got for multiplying matrices together. I hope you learned a bunch. I hope you get that song stuck in your head for the rest of the day. This is Mr. P signing off. If you have any questions, send a message to your instructor, and have a most excellent rest of your day.